Hey all, welcome back to my channel Ready. In the previous video, we have seen the basics of NumPy. So in this video, we are going to deep dive into NumPy and we are going to see the further functionalities of NumPy library when it comes to AI, machine learning and data science, specifically in handling arrays. Yes, let's get started. So for the first step, each and every time when you are using NumPy library, the first thing that you have to do is you have to import it. So the common method of importing is importing it using alias np. So importing NumPy as np. So this is my first step. Followed by that, I'm trying to create NumPy arrays. In the previous video, we have already created NumPy arrays, right? So what is special about creating arrays here? So here we are trying to create arrays with specific elements that I specify here. So in the previous video, we have seen how to create an array like this. But there is a possibility you can just specify the elements like zeros, ones, and you just need to add the number of rows and columns that my array should have. So my NumPy array will understand what you are giving here and it will create array like this. So it is actually a matrix with 4 rows and 3 columns. So next we are creating a matrix with 4 rows and 2 columns. So the one thing that you have to notice here is see all the elements that based on what I specified here, zeros and ones, it is getting created. For this, what as I have to use a syntax is I'm using variable name. So I'm creating a variable name for that. Inside that np.zeros. So after specifying np.zeros, I'm saying to my NumPy, my coding, you have to create an array that is filled with zeros. Then I'm specifying number of rows and columns. So the first thing that number you are giving here is considered as rows. The second number that you are giving here is taken as columns. So for ones, the same thing works in the same way. Followed by that, I could specify the range 0 to 10 likewise. The numbers that it should be used for creating an array. Followed by that, I can give the number of steps it should move for creating an array like this 0, 2, 4, 6 and 8. So what is happening? What is going on here? It is not actually arrange. Some might mispronounce it just by seeing this for the first time. This is actually arrange. So the use of this arrange is you can specify the range, starting value, ending value and the number of steps it should move. Next to that, I'm giving linspace. Linspace is used as similar to arrange, but it is quite different. It is not about number of steps. It is about number of divisions. So if I am giving a range of 0 to 1, how this limit should be divided into. So inside 0, 1, 1, how it could be divided? It could be divided here. If I am specifying 5 with linspace, the total range, based on the total range that I have specified, it will be splitted into 5 different parts. 0, 0 0.25, 0 0.5, 0 0.75 and finally 1. That is how this linspace works. This linspace and arrange is completely different. This particular starting value and ending value is similar for arrange and linspace, but the value that you give at the last, it makes the changes. In our arrange, it is used, the last value that you give is used for making the number of steps. It is used for deciding the number of steps. And in linspace, it is used for dividing the given range into number of parts. So this number 5 specifically divides the given range into number of parts. So if I give 5 here, the given range, and it's divided into 5 parts, 5 equal parts. And finally, I'm trying to print all the values that I stored inside all these variables. So for our first time, I'm creating an array, right? So it printed 1, 2, and 3. Next to that, I'm creating a matrix with zeros, filled with zeros, and I'm specifying 4 as a number of row and 3 as a number of column. So with 4 rows and 3 columns, it is creating a matrix. And next to that, I'm creating a matrix with ones, filled with ones, which has 4 rows and 2 columns. Followed by that, I'm giving a range. Inside a range, I'm specifying the range and I'm giving the number of steps. So what is going to happen here? It will create an array with this number of steps specified, and 10 is considered as an ending value, right? How range works. At the ending value, n minus 1 will happen. So 10 minus 1. So it is like 0, 2, 4, 6 and 8 because I have specified here 2 as a step. So that's how it works. Next to that, I have given linspace. How linspace works? It is used for splitting the given range into the number of paths that is specified at the end. So I have given 5 here. So it is split as 0, 0.25, 0.5, 0.75 and 1. So that is the difference between a range and a linspace. In Python, specifically in NumPy arrays, I can decide the data type. I can specify the data type here, even though it is an integer. See, look at this array. Have a look. This is actually an integer, right? But I've specified here as float. My NumPy array will consider it as float if I specify it as float here. So let's run and see. See the output. If I didn't specify this as float, let's see the data type. So for printing the data type, what I simply need to do is after storing my array inside a variable name, using print, I'm calling the name of the variable and I need to give .d type. So it will print the data type. If I didn't give float as a data type, it is printing as int. If I specify the data type as float, it will get printed as float. That is how specifying data type inside NumPy array makes changes. So if I'm creating any arrays, I can see the number of rows and columns. If it is looking like if it is a two-dimensional array, it might have rows and columns, right? I can see the number of rows and columns. I can see the number of elements inside my array. I can see the total number of columns alone, the total number of rows alone. So for that, we do have functions in NumPy. Let's see one by one. The first method is array.shape. It is used for seeing the number of rows and columns. See, in this given array, I have two lists, right? So first list is considered as my first row and second is considered as my second row. So based on that, if I'm trying to print the shape, it will print the number of rows on the first place and number of columns on the second place. Followed by that, I'm giving array.size. Size is used for printing the number of elements inside my array. So see, the number of elements here is 6. So the output is 6. Followed by that, I'm giving ndim. So it is number of dimensions. That is the function meaning. So it is used for printing the number of rows. So see how many rows do we have? We just have 2 rows. So the output is 2. So that's simple. That is how simply we could see the number of rows and columns. We can see the number of elements. We can see the number of rows alone using NumPy. That simple it is. See the number of lines of coding we are using here. So that is why we are using Python for data science, AI and machine learning, because the process, the number of steps that we are going to use for cleaning the data, handling it and finding insights, for doing some automation, it is definitely complicated. It's a time consuming task. So when my programming language is simple, that is going to be easier. That is why we choose Python as a programming language for that particular technology. Next, reshaping. If I create an array using a range, I'm just specifying the range. It is from 1 to 7. So it will create an NumPy array from 1 to 6. Followed by that, I'm trying to print it and see how my array is looking like. This is how my array is actually looking like. Followed by that, what I'm doing here is I'm just giving array.reshape of 2, 3. So now this array will convert it into a matrix with 2 rows and columns. So reshape is used for converting my given array with based on how I specify the numbers inside my reshape, it will get converted into a matrix with number of rows and number of columns that I specified. So here I have given the number of rows as 2 and I have given the number of columns as 3, right? So based on what I have specified, the output is becoming this way. So first I create an array with 6 elements, followed by that after applying reshape, it got converted into a matrix with 2 rows and 3 columns. Next, indexing and slicing. It is a simple concept we have applied in string methods, list and all, right? So you might have idea about it. It is simple. Just by using an index, you are trying to access an element or printing an element. Slicing is used for printing an element from particular index to particular index. So let's see in arrays how we are going to do that. So here I am specifying the index is 0, right? What it will print? It will not just print 10. So in this, it is actually a two-dimensional array, right? So here this is my first element and this is my second element in my given array. So the whole list, the first list is considered as my first element and the second list is considered as my second element. So based on that, if I specify array of 0, so in my first index, I have this list 10, 20 and 30. So that will get printed here. If I specify the index like this, it's from starting to 1, what it will actually print is, it will just print my first element, the element in my first index from both the list. So if I give 2 here, what will get printed then? So if I give 1, the elements on my first index is getting printed. Let's see if you are guessing right or not. I know, you guessed it right. Next to that, Boolean indexing. So Boolean indexing is not just about indexing. It is about applying some conditions and printing my list of all elements that I want based on specifying the condition. If I use any of the relational operators or comparison operators here I am using greater than operator. Why I need that? If I want to print the list of all elements that are less than or greater than a particular value, that in arrays is called as Boolean indexing. So for that, what steps we have to follow is, first I need to create an array, or I am storing an existing array. Likewise, you imagine. Followed by that, I am using array of, inside a square bracket, I am calling the variable name and I am giving greater than 20. So see, inside this array I have 4 elements, 10, 20, 30 and 40. So when I give array greater than 20, the output would be, obviously, it will print the elements that are greater than 20. So the output would be obviously 30 and 40. That's what we got as an output. So if I give less than 20, what would be the output? We just have 10 there, right? So if I want 22, what I have to do? I need to give less than or equal to, because 20, if I want 20 also need, if I also want 20 to taken into consideration, what I have to do is I need to give less than or equal to or greater than or equal to. So 20 will also be taken into consideration while printing. So followed by that, we have, so this thing is something we have already seen in the previous video, right? So after creating an array, just by using this, calling the name of a particular array, Numpy array, if I give plus 10, if I give into 3, what it will do? It will add 10 to all my elements on my Numpy array. So doing all the mathematical operations using Numpy is so simple. So that is how it works. It is called as broadcasting. So what is broadcasting? If I create an Numpy array and just by specifying the particular element that need to be added to all elements in my particular array, that is called as broadcasting. I can add, I can do multiplication, I can do any arithmetic operations as per my requirement. If I want to do square root of all these elements that I've specified based on array I created, it could be easily done just by using np dot square root of array. So what I created is variable and I created that Numpy array. So this simple is broadcasting an Numpy array. Next we have statistics. So what generally is statistics? Working with numbers, and that is specifically used for finding the mean value, median value. But what is the use of finding those mean, median and mode value? It is used for understanding my data. If I see the average of data, I can understand the common marks that students score. So if I find the mode of value, I can see the common marks that students scored. If I see the median value, what I can understand, I can see the middle value of my all the numbers. So for understanding what is going on, So based on my historical data in business, I can predict my future sales. So for that, I have to do basic statistical analysis. Next to that, I have to apply machine learning models. So for that, the basic step that I have to do is I need to apply some statistical functions to understand what is going on inside my data. So that is why we need statistics in my AI, data science, and machine learning. So while learning every concept, you have to understand why I am learning these concepts. So if you have any doubts, without hesitation, search for that and understand. Learn so many things. So learning that so many things that you want to understand, that will keep you on the growing stage. Don't hesitate to search and learn. Don't procrastinate it. That is very important. So here we are doing some statistical applications that are very simple. So first I'm using dot sum. After creating an array, if I use dot sum from my statistical functions, what it will do is it will add all my numbers inside this array. So if I add all these numbers, output would be 100. And next to that, I'm applying np.me. So this is how the syntax will look like. See how simple is the syntax? So it's too easy, right, to remember. The one thing that you should keep in mind is this bracket. This is something that you could forget. And should remember that you should use numpy, np along with dot sum. If you forget any of this, you might expect a result, but it will throw an error. You will get confused at the stage, especially when you have interview or while doing projects. So if you keep on practicing only, then you will remember. You might feel like Python is easy, right? But remembering is the tedious task here because you have already seen so many functions, right? So even now, we do have so many functions. So yes, that's why. So next to that, I'm trying to apply mean. Mean is generally used for finding an average value. And min and max. It is actually short form of minimum and maximum value in my given array. And finally, standard deviation. So it is actually a statistical concept which is used for finding how my values, my average values are on a distance based on, we have a simple formula for standard deviation. But just by using std in Python, it will print my standard deviation value. Inside, all the calculations will happen. So that is how they built a library. That is why I told that Python is an apt language for AI, ML, and data science. So just by using all these functions in my NumPy, I can see all the summaries of my given array. I can print the sum, I can see my mean, the average, minimum value, maximum value, and standard deviation value. See the output, how clear it is. So that simply you can use statistics into my coding environment when I use Python. Next, access concept. Just by looking at this coding, you can think, oh, it's a tedious task. No, it's very simple. Let me make it easier. So for that, what you have to do is first you need to create an array. So here I'm creating a two-dimensional array. A multi-dimensional array. Let's call it this way. So here I am creating two arrays and adding that inside, right? So it is actually a matrix. So 1, 2, 3 is on my first row and 4, 5, 6. The second list is considered as my second row of a matrix. So when I use np.sum and I give array of axis, array comma axis equal to 0, what it will do is it will add both the list. Both the rows. So my first row will get added to my second row. So 1 will get added to 4, 2 will get added to 5, 3 will get added to 6. So that is why we got output as 5, 7 and 9. And next to that, when I give axis as 1, it will add vertically. So in that sense, what will happen is every elements in my row, the same row will get added. 1 plus 2 plus 3, it's 6. And my second row, 4 plus 5 plus 6. So it is 15. So that is how this axis is working. So using axis, you can control row-wise and column-wise operations, specifically when it comes to mathematical applications. So followed by that, we have broadcasting. It is simple. We have already seen here, right? This in technical terms, specifically in NumPy, it is called as broadcasting. See, after creating an array, if I just add plus 5, it will add 5 to all the elements in my array. So that's how I got 6, 7 and 8 as an output. So if I add 10 here, what would be the output? I know you guessed it right. It is 11, 12 and 3. Because it's simple, right? Yeah. Next, copy versus view. So we are just trying to understand the memory behavior of arrays in Python, specifically when it comes to NumPy. So for that, I'm creating an array. So after creating an array, I am giving inside a variable a.view and a.copy to two different variables. Followed by that, C for a given index. Based on an index, I am adding a particular element 100. So here what a.view and a.copy will do generally. So a.view is generally used for seeing the changes that I made to my existing array, and copy is used for seeing my array that I created for the first time. So that is the use of these two methods in my NumPy array. So first I'm creating an array like this 1, 2 and 3. After that, in this particular index I'm adding 100, right? So my A is now 1, 2 and 3. It's not 1, 2 and 3, it's 100, 2 and 3 because 1 got replaced with 100. So when I try to print A, B and C in my first array, as 100 replaced 1, so the output is 100, 2 and 3. So when I try to see the changes using a.view, it is 100, 2 and 3. When I use a.copy and I store that inside C, so it is 1, 2 and 3. Why? Because it is showing my array when I didn't make any changes, how it was created for the first time. So that is how this functions in NumPy array work, and that is how array is memorized too. Next, stack and split. This is such an easy concept. Just by seeing the name, it could look complicated, but it's actually an easy concept that you could remember. What simply happens here is, first I'm creating two different arrays for A and B with elements like 1, 2 and 10 and 4, 5 and 6. Followed by that, just by using hstack and calling those two arrays inside a bracket, what will happen here is it will just concatenate both the arrays. So what is concatenation? It will just merge both the arrays. 1, 2 and 10, 4, 5 and 6 both got merged, and now it is a common array. It got converted into a single array. Followed by that, I am using array.split. So array split function in NumPy is used for splitting my given array into specified number of elements. So when I give 3 here, what are the number of elements I have inside A? I have 1, 2 and 10, right? So see the output, array of 1, array of 2, array of 10. So it is used for splitting my array into the specified number of elements. When I give 3 here, it got splitted into three number of elements. So that is how stack and split work. So I believe you have clarity on this array methods and how to create an array, how data type make changes, and you have clarity on shape, size and dimensions, and you have clarity on reshaping. We have seen about indexing, slicing, and we have also seen about Boolean indexing. So it's simple. It is actually applying conditions inside my specified array. Mathematical operations, how to apply them. It is called as broadcasting. Statistics. It's simple, right? It's too easy than you thought. Next, copy and view. How arrays generally store the elements. How when I try to see the elements after changes, how it makes changes. So that is what. Next, how stack and split works. Yeah. So if you have any doubts on today's session, without hesitation, you can ask them on comments. Bye for now. We'll meet you next week.